my welcome to day 3 of this really exciting TFN conference. And as Mike said, I want to focus today in the next 15 minutes or so on data and related technologies and how data is really becoming the new oil for the smart manufacturing revolution. So I'll start with a little bit of history. The reasons for that should become apparent. And then we'll move on to look at some key technology trends, in particular, Internet of Things, artificial intelligence and 5G networking. And then after that, we'll move on to see how that convergence of technology is being applied in a range of different smart manufacturing and Industry 4.0 business applications. So I said about a little bit of history. So here we go. On the left of your screen there, you can see in 1948, the world's first stored program digital computer executed its first program in Manchester, UK. And as you can see there in the image, the computer was kind of the size of a small warehouse. 60 years later, of course, we have tiny chips with many orders of magnitude more power than that warehouse-filling computer, which require a lot less energy to execute that power, and which are of pretty much negligible size and weight and cost an awful lot less. So miniaturization, falling costs, and so on and so forth. So that ends the history lesson, other than to say, because of that miniaturization and those falling costs, reduced power requirements and so forth, computers and sensors are now everywhere. So in a typical vehicle, even a relatively simple vehicle, you'll have dozens of sensors and computers, and many, many more in more sophisticated vehicles. So computers are now everywhere, and sensors are also everywhere. We've seen sensors in cattle, in running shoes, computational ability in all kinds of white goods, in smart buildings, biomedical chips embedded into humans, and most centrally and relevant to today's talk, of course, into all kinds of smart manufacturing plant. So let's turn now to look at some of those key technology trends that I mentioned: Internet of Things, AI, and 5G. So the Internet of Things, the things in this context is simply anything out in the environment which can sense data about that environment and send that over a network so that we can get access to that data and process it. And we've already seen the wide range of different kinds of areas where sensors are now embedded. We need to turn that raw data into information, of course. So to understand that a particular number is a temperature in a given location, measured in degrees centigrade, for example. And then when we've gathered all this information and aggregated it together, we can use AI and other techniques to extract knowledge and insight, actionable insight from that data, which leads me neatly onto AI. I always think the simplest definition of AI is simply computer behavior that would be considered intelligent if we observed that behavior in a human being. And in recent years, AI has really made some significant advances. So the IBM Watson computer was able to beat human all-comers in a TV general knowledge quiz show. There was a Go playing computer program which beat the world champion and even uncovered some strategies that humans had never seen before. We're seeing AI embedded in finance systems, in other sectors as well. And we're even seeing AI able to now perform better diagnoses in some areas than medical specialists. And really one of the core features of this advance that we've seen in recent years has been a subpart of AI called machine learning, which is where essentially you throw a lot of examples, a vast amount of data, back to that data theme again, at a computer, and the computer can learn from that data, those examples, such that when it sees new examples, new data, it can act appropriately and classify and respond to that new example, that new data in an intelligent way. So that's AI. My third technology pillar is 5G networking. And there are really three key features for 5G networking. The first is dubbed MMTC in the jargon, Message Machine Type Communications. This is the ability to have a really high density of devices, so up to 1 million devices per square kilometre can all be connected. EMBB refers to the massive bandwidth that we see with 5G, up to 10 gig per second. And then we've got URLLC, which is very low latency. So the ability for for almost zero delay to be built into the network to very quickly react and respond in some critical application areas. So those are our 3 key pillars: IoT, AI, and 5G networking. And if we think about those pillars, they're all about data in my mind. IoT is enabling us to sense more data than ever before. AI is about extracting more insight from that data than ever before. And finally, 5G is about moving that data around more rapidly and at higher volumes than ever before. And as a colleague said to me the other day, we need to be data-driven. We were discussing the possible solution to a particular problem, and I was proposing one thing, and my colleague said to me, very insightfully, the data has a better idea. And we're now getting to the stage where, human intuition has a certain role to play, of course, and we'll always need humans in the loop. But increasingly, the data has the idea. The data is where we get the evidence and the insight, which is really making us an evidence-driven organisations. So I just want to unpack in a little bit more detail some of the key technologies that are relevant to smart manufacturing and Industry 4.0. And all of these 5 that I've listed here all use IoT and AI and networking to some different degree. But this is kind of the next level of detail down, if you like. So we have autonomous mobile robots. Typically, these maneuver around factory environments. They can carry, they can trace and inspect products and parts, taking the human out of the loop to some extent. Augmented reality, probably an idea many of you are familiar with. This can increase technician productivity and accuracy by kind of providing visual overlays and instructions on a screen right in front of the technician's line of sight, removing the need to switch continuously between a manual and the equipment that's under consideration, and to flick around in the manual for the most relevant part. So a very context-sensitive delivery of relevant information. Collaborative robots, sometimes called cobots, can help operators perform tasks like drilling, inspection, and we could be moving in the future to inspection of 100% of products before they leave a factory, rather than the kind of sampling that we tend to do in some areas today. Of course, that will lead to a big increase in customer satisfaction. Digital twins, again, a concept some of you may be familiar with, the ability to create a virtual copy of a particular facility, could be a factory or sub-part of a factory, which allows us to do kind of what-if scenario planning, to run different tests on what if this happened or that happened, without the need to actually interfere with the physical plant itself. So we don't have to physically interrupt the factory at no downtime and so on. And then the 5th and final one is asset condition monitoring, where we collect and monitor data about machine performance. And this can lead to predictive maintenance, where we anticipate faults before they become critical, before the machine has to stop. And that can reduce the amount of unplanned downtime and the cost of replacement parts. So let's move on now in the final part of this talk to look at some of the business applications and benefits. And this is a really nice infographic that came from Nokia originally, and I'm not going to go through it in detail. I really haven't got time in the time that I have available. But this is really highlighting some of the many areas where we can start to automate operations in industrial environments through this convergence of technologies that I've been talking about. And I'd like to move on to talk about some more specific examples. So this is a BT, an own use example where we're actually adding IoT to some of our legacy equipment in some of our exchanges. Temperature and humidity significantly affect plant performance in our exchanges. And by monitoring these 24/7 using technology, instead of sending people to make the measurements or to observe the measurements, we can much better manage the air and the environment in those buildings. And this has led to reduced equipment costs and project savings in the millions of pounds. Smart factories. I wanted to talk briefly about in-blade technology, a very interesting technology company in Mexico, and they've deployed IoT sensors to monitor temperature and vibration on industrial motors. And this is back to that predictive maintenance idea that I was talking about earlier. So monitoring these motors has led to a significant reduction in maintenance and failure costs. And they did an interesting example, or an interesting extrapolation. And apparently they estimated that if this technology, these techniques were applied to all the industrial plant in the EU, you could be looking at potential savings of 70 billion euros per annum. So really significant potential cost savings there. Robot highways. This is a project that we're running in BT with a bunch of partners, a collaborative project, which I'm really excited about this one, actually. We're aiming to deliver a fully automated and carbon neutral fruit farm using industrial robots of the sort you can see on the left of your picture there. And those robots are going to support multiple use cases across the farm, everything from fruit detection and forecasting the harvest that it's going to be delivered in a given year, to disease control and automatic crop spraying in a precision agriculture way, fruit picking, logistics support, fleet operation and packing. So we the robots will take the fruit ready to be packed, ready to be taken away by the hauliers. And as I say, these robots are all carbon neutral. There are EV charging points for the robots, which they can go off and recharge themselves when they realise they're getting low on battery. And those EV charging points are solar powered. So a really interesting and challenging project. And this is just a picture of one of the robots about to pick a strawberry. So that's what it actually looks like. As I say, Robot Highways is aiming to deliver the largest known global demonstration of a carbon-neutral robotic support for the end-to-end fruit farming system. So quite an ambitious one. And just to finish, three more example applications and benefits. We're working with Worcestershire, with Bosch at their Worcester facility, to look at the use of automated guided vehicles in the factory environment. Ericsson, an interesting use case. They deployed augmented reality troubleshooting, as we just touched on previously, in their factory in Tallinn, and they've estimated that the average fault time detection reduction can boost productivity by up to 50%. And then finally, Black & Decker, in terms of process efficiency, they deployed networked RFID tags to a very large number of materials, almost every material, I believe, in their manufacturing. A better visibility of the production process and the ability to optimize those processes. And they improved utilization rates from 80 to 90% and reduced the number of first-time defects by 16% using that technology. So in conclusion then, data from multiple sources, as we've seen, continues to grow very, very rapidly. IoT technology is becoming ubiquitous to sense and transmit that data. AI can increasingly be applied to extract insight and to offer greater automation. And then 5G networking, of course, provides the infrastructure to really take advantage of these technologies. So I think hopefully we've seen that Industry 4.0 and smart manufacturing, there's impact and applications in almost every industry sector with regard to those technologies. And that concludes what I wanted to say. Thank you very much for your time, and hope you found that of interest. Thank you.